Starting Ansys Workbench. So before we get started, let's go through a quick overview of what we'll be covering in this module. First, I'll be going over some of the prerequisites you'll need in order to continue with the course. I'll then briefly explain why we use Ansys Workbench, and then I'll do a quick overview of the finite element method and how it applies to our problem. Finally, we'll start Ansys Workbench, and then we'll go over the interface, the units, importing CAD files, and finally, the engineering data application, where you'll define your materials for the analysis. Prerequisites. First, you'll need Ansys version 17 already installed and configured, along with either a mechanical or structural license. If you don't know what any of these are, then you should please contact your Ansys vendor for more information, as this course will not cover how to install Ansys Workbench. Secondly, you'll need to have a good knowledge of the finite element theory, which means that you would have a solid engineering background, and you should be familiar with some of the governing finite element equations, such as stiffness times displacement equals force, as well as some basic knowledge of element types, such as the tetrahedron and hexahedron and their node counts. So why use Ansys software? Well, Ansys is a useful tool to solve problems with complicated geometries, loadings, and material properties where analytical or hand calculation solutions are difficult to obtain. In our problem, for example, we have a lifting lug design with a bolted connection and multiple fillet radiuses and somewhat complex geometries. So let's say we want to solve the stress in every area of the system and find the location of maximum stress. It would be possible, however, it would be much more time-consuming and less accurate when compared to the finite element method. So we also use Ansys to ensure the design safety of our equipment. So we'll be able to answer some of the following important questions, such as at what load will my lifting lug fail, and where would the maximum stress occur in the system? And finally, it'll also be able to help us provide design insights and optimization, which could potentially save us material costs and increase the components factor of safety. So here's a quick finite element method workflow overview. One will start off with a physical model they would like to analyze. They will then take the model and convert it to a 3D CAD model and split the model into many elements, hence the name finite element. After applying loading and boundary conditions, we will then solve the model and obtain the results, which can include deformation, stress, and many other types of results. So in our case, the physical model is the lifting lug, and the FEM model will be the conversion of the real model into a 3D CAD model, and then after dividing the model into finite elements and applying the correct load and boundary conditions, we'll finally obtain our stress results, deformation, and other results. So, what are we waiting for? Let's go ahead and start Ansys Workbench. So once you open up Ansys, you'll be presented with a Getting Started page with some useful tips on how to begin a project, as well as a link to some helpful tutorials. I'm just going to go ahead and uncheck this for now and click on OK because I don't want this pop-up to keep on showing up every time I launch Ansys. If you ever want to bring this page back up, you can always go ahead into the Tools, Options, and under the Project Management tab, you will see here the checkbox for Show Getting Started dialog. You can go ahead and check that, and then click on OK, and then every time you restart Ansys, you'll always get that page back up again. So when you open up a new project in Ansys Workbench, it opens to the Project tab, which is just one of many tabs that can be opened in Workbench, but it's the main workspace in which you'll build your analysis. Like all tabs, the Project tab is made up of different views that can be reconfigured according to the information you want to see. By default, the Project tab has the Toolbox view and the Project Schematic view. The Toolbox view contains the types of data you can add to the project schematic. The systems are divided into categories, which can be expanded or collapsed in order to show or hide the system in that category. The analysis systems are ready-made stencils that include all the individual components needed for a common analysis, such as the geometry, the mesh, the solver, and post-processor. The component systems are the individual building blocks for each stage of these analyses. So one could create their own analysis system by using these blocks. If you decide to create a custom system and would like to save it, it will be shown in the Custom Systems category right here. Finally, the Design Exploration category right here provides tools for optimizing the design and understanding the parametric response of the systems. Now, these toolboxes can also be customized to add or remove systems as needed in order to personalize your workspace. And if you don't see any systems here on the left, then you most likely have a licensing issue and you should contact your Ansys vendor for support. The mechanical or structural license that I mentioned before should give you access to the analysis system called Static Structural, which is the only system we'll be using for this course. So you don't have to worry about any other systems. Isn't that easy? Next, at the top of Workbench, you have the menu bar, which contains the File menu, where you can go ahead and create a new project, open a project, save a project, as well as Archive, which is slightly different. This basically saves all the project files into one single file, which makes it easy to send over email. And then if you ever receive that, you can also go ahead and click on Restore Archive, which will expand this archive project, and we'll go ahead and open it that way. You have the View menu, where you can go ahead and reset your workspace in case you made some changes you didn't like. And you can also go ahead and turn on and off some views that you don't want to see. Like if we want to hide the toolbox, we can go ahead and click on this right now, and as you can see, the toolbox disappears. If we go ahead and click on it again, we see that it reappears. We have the Tools menu, which contains some license preferences as well as Ansys options. We have the Units menu, where you can go ahead and change your units. The Extensions menu, where if you go on Ansys.com, you can go ahead and download some extra extensions which can further enhance your Ansys experience. The Jobs menu, where you can go ahead and launch a solve on a remote machine. And finally, you can click on the Help menu, and more specifically the Ansys Workbench help, which contains all the documentation for Ansys that you'll need to get started. At the bottom, we have the status bar, which shows ready and a green light. If this was red, this would mean that Ansys is currently either loading an operation or maybe loading an analysis system. On the right here, we have some quick access tools to the remote job monitor, the progress, as well as the Ansys messages, which is quite useful. So you can go ahead and check this box right now. So now that we've gone over the Ansys interface, let's go ahead and start the project. So the first thing we're going to do is either double-click on the static structural analysis or hold and drag it onto the project schematic and then let go. This will basically add the analysis system to the schematic. Now Ansys will automatically ask you to name this analysis, so we're going to go ahead and type lifting lug, and then we're going to hit enter. Now as you can see, the workflow is from top to bottom. And as each stage is complete, the icon on the right-hand side will change. Now these icons are called cell states. So let me just give you a quick overview of each one of these cell states. So the first one is the hollow question mark called unfulfilled. This means that the required upstream data doesn't exist. So in this case, cell 4 is not updated and therefore doesn't exist, so cell 5 is unfulfilled. The second one is the green arrows called refresh required. This means that the upstream data has changed since the last refresh or update, so you may need to update this cell. The third one is the solid question mark, which means attention required. So it means all of the cell's inputs are current, however you must take some kind of corrective action in order to proceed. The fourth one, which is the yellow lightning bolt, means an update is required. So you can go ahead and double click on the cell and click on update in order to update the cell. The green check mark means up to date, so this cell is completely up to date. And the green check mark with the yellow arrow means that the input changes are pending. So the cell is locally up to date but may change when next updated as a result of changes made to the upstream cells. And here are some other cell states which I will not be covering right now, but you can go ahead and find them in the Help menu. So coming back to the project schematic, we can actually build the same analysis system using the component systems instead as an alternative workflow. So we can go ahead and individually create this system by, let's say, selecting the geometry and dragging it into the project schematic, and then going ahead and then dragging the mechanical model on top of the geometry in order to link it together to create the mechanical model. And then finally we can go ahead and drop a static structural on cell number 4 to link all that together into the static structural. So this is basically another way of creating the same workflow. However, in this case you can create individual blocks. So let's say we can start with the geometry and then create our mesh, but then let's say make a thermal analysis instead, so we can go ahead and drop that there. And then now you can see, using the same geometry, we can run the static structural and thermal models side by side. So the square connector shows that the geometry created in this previous cell here is being shared with this cell over here. So any modifications to this one will be automatically updated in this cell. Now if we add, let's say, a steady state thermal analysis and we drag it onto our schematic over here, and let's say we ran a static structural analysis and we want to use the results of this structural analysis as an input to our thermal state model, well, we can go ahead and click on, let's say, the solution and drag it into cell number 4, the model, and this will create a round connector. And the round connector means that the results of this analysis is being transferred as an input condition for the next analysis. So should you ever want to rename an analysis system, you can go ahead and click on the small down arrow on top of each system. And then this will bring up a small pop-up menu, and you can go ahead and click on the rename. And then here you can type in renamed part. And there you have it. And this menu actually also has a bunch of other features that you can do, such as update the analysis, create a copy of it, replace it with a different system, clear its generated data, delete it, see the properties, and even add a note. So we're just going to go ahead and now quickly delete all of these systems and click on OK when the pop-up menu comes. So we're going to delete the steady state thermal, we're going to delete the static structural, delete the mechanical model, and then finally we're going to delete the geometry. So now that all the components are deleted, let's go ahead and save the project. So we're going to go ahead and click on the File menu and click on the Save As button. Once here, we're just going to call this Lifting Lug Tutorial. And then click on the Save button right here. Now that our project is saved, I want to just go into more detail about the View Files tab. So let's click on the View and then click on Files to show the files. So this will enable you to identify the individual files on your disk for each stage of the project. The resulting table will cross-reference the directory and file names with the project cells. So as you can see, the Workbench project comprises of many files and directories on the disk. As mentioned before, if you need to archive the project or bundle it to send, use the Archive tool, which generates a single zip of the entire project. So let's go ahead and do that now and click on Save. When archiving, you can either choose whether to include the computed results file or not. Omitting these results file can greatly reduce the file size of the archive, which could make it small enough to even send over email. So let's go ahead and uncheck the results option and click on Archive. Now, let's go ahead and restore this archive. So let's go into the File menu, click on Restore Archive, and now we have our archived file here, which is saved as a WPBZ file. Click on the archive and then click on Open. Once you open it, Ansys will automatically ask you where to save this file. So we're going to go ahead and save it in the same directory and click on Save. And we're going to go ahead and overwrite the existing project. So that's how you open up an archived file. So moving on to the Units menu in Ansys Workbench, you can go ahead and select from different types of predefined unit systems such as SI, metric, or US customary. Now this checkbox here, display values as defined, means that this will use the units from the source. So let's say if you imported a CAD model, this will use the default values of the source instead of using the values in your project units. So this is where you can go ahead and change that to force Ansys to use the values in project units or to use it from the source. The last option here is the unit system. So let's go ahead and click on that right now. Once you have that open, let's go ahead and make this box slightly bigger by dragging onto this edge and moving it to the right. So as you can see here on the left-hand side, you have a predefined set of unit systems. The column B here shows you the active project unit system. So as you can see, we've selected the number 3, metric. Column C is basically the default unit system. So every time you launch Ansys, this will be the default unit system that Ansys will go to, depending on which one you choose. Column D basically hides the other unit systems that you're not interested in seeing in the Units menu. So let's say you want to change the default unit system to US customary. You can go ahead and click on that right there, and that will change the default to US customary. If you wanted to hide a few other unit systems, such as US engineering, you can go ahead and click on this checkbox, and now it will not show up in the unit system anymore. Now at the bottom here, you can see you can also have the options to either duplicate, delete, import, or export a unit system. So let's say we wanted to make our own custom system. We can go ahead and start off with a default system, say the metric system, and click on duplicate. This will duplicate the system, and you can scroll down to the bottom here, and now you'll see something called custom unit system. Now let's say we want to make this our default system. We can go ahead and check this box and check this one right here to make it into our active project and the default system. Now with this custom unit system, you can go ahead and double click on this and rename this to whatever you want. Let's call this metric 2 and hit enter. Now as you can see on the right, you have column A, which is the quantity name, and column B, which is the unit. So you can go ahead and change the default values, let's say for the angle, from radian to degrees, or say change the length from meters to millimeters. Now once that's done, this will automatically save it in the project. But if you want to send this to a friend, you can go ahead and click on the export button, and this will save the unit system as an XML file. You can also import it if somebody sends you a custom unit system, and it will import it into your unit system library. Now to delete this system, it must not be active. So let's go ahead and click on number 3 and make this one the default system again. And let's click on number 20, the metric 2, and click on delete. Now once that's done, we can go ahead and click on close. So let's talk a little bit about importing CAD geometries. Ansys has numerous geometry interfaces that are available for commercial CAD systems, such as AutoCAD, SolidWorks, and even Parasolid geometries. So all of these geometries can be easily imported into Ansys using any type of license. However, if you want to have something called an associative geometry interface, which means that, let's say you have SolidWorks installed and you have Ansys installed, you can go ahead and change the model in SolidWorks, and Ansys will automatically be linked to that model and update it in Ansys Workbench. Now for this, you might need some special licenses, so once again, you should contact your vendor regarding which geometry interface licenses you will need for your project. Now there are many different ways to import the geometry, but one of the ways is to go ahead and select cell number 3, which is called geometry, and right-click on it, and then you will see the option here to import geometry. So here's where you can go ahead and click browse, and you can browse for your different type of geometry. And if you click on this scroll menu here, you can see all the different types of compatible geometries that I can import. So I have the satfile.sat file, which is extremely common. I have IGES files, I have Parasolid, I have Solid Edge, SolidWorks, etc. So let's just click cancel for now. Now the next thing I want to mention are the properties when importing CAD geometries. So let's go ahead and click on cell number 3 Geometry, right-click, and click on Properties to open up the Properties pane window. You can also access this menu by clicking on View and then Properties. The Properties window will pop up here on the right side of Workbench. In order to get a better view of it, let's go ahead and close this Files window. We can either close it by clicking on this X here, or once again we can go into the View menu and click on Files to hide it. So I will not be going over all of these options with you, but I will be going over the most important ones. So let's take a look at basic geometry options. As you can see here, you can filter what type of geometry you want Ansys to import into your project. The CAD file could contain solid bodies, surface, and line bodies, so it's up to you to decide what type of geometry you need. As you can see by default, all of these three options are checked. However, this filter can be very useful at times to eliminate bodies that could cause problems during an import. Next are the parameters and attributes. An example of a parameter or attribute could be, for example, a defined dimension on the part, which is given a label or a name to it. So if these boxes are checked, Ansys will by default import all the parameters and attributes defined in the source geometry file. But say you only want to import a specific parameter into Ansys, here is where the parameter and attribute key come in. You can tell Ansys to only import parameters or attributes that have this key or piece of text in it. So say we define a radius called fillet1 and another radius called ds_fillet1. If we leave this field blank, Ansys will import both of these dimensions. However, if we input ds as a parameter key, Ansys will only input ds_fillet1 as a parameter into Ansys. Moving on to named selections, you can think of this as a group of surfaces or even as a specific point on a geometry that the user has given a name to. So for example, say in your CAD file you had a collection of 4 nuts and bolts, and the user created a group or named selection called bolts. Ansys will also be able to import this type of feature. And the last option here is material properties, where if the material properties were defined in the external CAD program, they can be imported into Ansys as well. Now I don't want to go into so much detail on advanced geometry options, but you can see here that you can also change the analysis type from 3D to 2D if you just want to do a 2D analysis. And you can also have the option to use associativity, as mentioned before. Let's say if you want to link up with an external CAD program such as SolidWorks and have real-time updates between them. And you can also import coordinate systems and many other features here which I will not cover, but once again you can find in the Help menu. So now that we've gone over the interface, working with the units, importing a CAD geometry file, let's have a look at the final part, which is the engineering data application. So to start it up, let's begin by double-clicking on cell number 2, Engineering Data. So the engineering data application is where you can provide controls for all your material properties within Ansys Workbench. So right in the center of engineering data, we can see something called Outline of Schematic A2. So this is where all of our materials will go for our specific project that we've created called Lifting Lug Tutorial. Now as you can see here, there is no materials that are specified, and Ansys asks us to click here to add a new material. Instead of making our own new material by clicking here, you can go and click on this tab called Engineering Data Sources. By clicking on this tab, you will see the whole Ansys library of different types of materials you can use for your project. You can also think of this as a list of preset materials. So in order to get more space here, let's go and close the Messages toolbox here at the bottom by clicking on this X button. So in Engineering Data Sources, you have general materials, some nonlinear materials, explicit materials for high-speed impact dynamics, thermal materials and fluid materials, and even composite material preset libraries for you. Now by default, the general materials is selected. And once it's selected, you can see over here the outline of general materials. So this is the whole library of general materials given to you by Ansys. So here on the left you have the materials such as air, aluminum alloy, concrete. And under column B you have the option to add this to your engineering data project. So by clicking on this button, this will add this material to your project view. Now the properties box below gives you the details of the material that's selected in the outline. So let's go ahead and select aluminum alloy. And as you can see here, the properties for outline row 4, aluminum alloy, are displayed right here. So you have the density, you have the Young's modulus, you have the yield strength and the ultimate strength, etc. And to the top right here, you have the property table, and just below it, the property chart. Now these two windows give you more detail about the property that you selected here in Properties of Outline. So here the density is selected by default, and in the property table you have the density and you have another column which shows the temperature. If the temperature is not specified, then you can see in the property chart window that the default is 0. Now let's say you want to modify a list of preset material libraries. You can go into the Engineering Data Sources view again, and under column B you'll see this little pencil icon. Now by checking one of these checkboxes, you can go ahead and now edit this material list. Now if you made the changes to this material list and you want to save it, you can go into column C and click on this button here to save your materials as a new XML file, and you can send it to a colleague or for technical support. And if you want to import a list of general materials, you can go and scroll down to the bottom here and click on this button to open an existing data source from a file. Now let's add structural steel to our project. So go into the Outline of General Materials window and let's scroll down till we find structural steel. So there we have it, structural steel. So we're going to click on this yellow plus sign to add it to our project. So once we've clicked on that, we can go now and click on the Engineering Data Sources toggle to go back into our project window, and now we can see here in the outline of A2 we have structural steel now in our project. So once added, we can now choose to modify the default properties of the structural steel in this window here. So we can go and bring this up, and now you can see that all these fields in column B are editable. So let's say you want to go and edit the density, you can double click on this value and you can erase it and edit it. And let's say you wanted to change the Young's modulus, you can also change the units for each individual property. So you can click on this Pascal here drop down menu and choose, let's say, megapascals. And then now you have it in 2e to the 5 megapascals. So once again you can double click on this and you can modify the material as you wish. Now Ansys doesn't include all the properties that you might need for your analysis. So that's why there's this toolbox here on the left. This toolbox gives you all the properties that you can possibly need to define a material in Ansys. So let's say for structural steel, we can go into, let's say, linear elastic properties, and as you can see, isotropic elasticity is grayed out. This means that it's already part of our material property, and we can find it right here in row 6, isotropic elasticity. Now, if let's say we wanted to add a different property and not make it isotropic but orthotropic, we can, let's say, click on this, drag it into any one of these rows and let go. Now as you can see, this overrides the isotropic elasticity property because now it is being defined as an orthotropic elasticity property. And this question mark means that you have to define some more parameters before continuing. So if you click on this plus sign here, you can see that now you can have all these parameters to define in each different direction for this type of property. So let's go ahead and remove this by right-clicking and deleting it. And then let's unsuppress the isotropic elasticity using this column here. So by default, if you add in a new material, Ansys will suppress it, but we want to now unsuppress it to get it back. So let's click on that. Now you can see the line is undone in this, and so that means it's unsuppressed. Let's say you had a nonlinear analysis to do. You can go back into Engineering Data Sources, and you can, let's say, go into General Nonlinear Materials, and let's move this down a little bit. And you can go and choose let's say, stainless steel nonlinear material or structural steel nonlinear material. And as you can see here, it has a bilinear isotropic hardening parameter. So this is the nonlinear curve for this material. So this is a default in Ansys again if you're doing a nonlinear analysis. However, let's say you wanted to add something more complex and add, let's say, a multilinear stress strain curve. Well, let's go back and uncheck engineering data sources and click on structural steel. We can go now into plasticity models and choose, let's say, a multilinear isotropic hardening property and drag it into our properties outline. And now, as you can see, I'm going to bring this window up, and now we have our multilinear isotropic hardening, and it asks us to fill out this table. And this table on the right is essentially the stress strain curve for this material. So we can go and put, let's say, 0.001 and put a stress of 250, and then let's say 0.002, and let's say 255, and etc., etc. And here you can add, you can keep going until, let's say, 0.2 millimeters per millimeters, and then say 256. And then here you have your custom multilinear stress strain curve. So for this tutorial, we're not going to be using nonlinear materials, but this is just to give you an idea of how to use the toolbox. Now you may have noticed this button called Filter Engineering Data. This is just a toggle button that, when selected, filters out all the material properties that are not relevant to the current study. So since we're doing a static structural analysis, you can see that all the other models are hidden. So if I uncheck this right now, you will see that it shows us all the different types of material models for any type of project. And now it added some magnetic materials and some electric material properties. And as you know, these are properties that we're not going to use in our project. So let's go ahead and keep that checked on and only have relevant properties for a project. Now, getting back to the properties outline, let's go and remove this multilinear isotropic hardening property. Click on delete. And now we're back to our general structural steel material. Finally, you can also add materials by clicking on this area here where it says click to add new material. So let's say you don't want to use a default material and you want to make your own material from scratch. You can click on this and you can define something, let's say, called new material, and hit enter, and this will define a new material for you. And as you can see in the properties, you have absolutely no properties here. So you would have to go and add them yourself. So let's say we go into the basic properties. You can add density, double click on it or drag it in. We can add, let's say we can enter this value as 7850, and then we can go and add a linear elastic isotropic property and drag that into the first field here. And then you can, etc., and you can make your own material this way. Now, something else that you might notice is this column B here. This could just change the color of your material. So during the analysis, if you want to show the model by color, you can use this here to define different colors to different materials. So that completes the engineering data tab. I'm just going to go and delete this new material because we will not be using it for a project, and we'll just be keeping structural steel for now. So let's click on the X button to quit out of engineering data and back into our project. So once back into our project, you can see here now the engineering data tab has a green check mark, which means it's updated. So there's a quick overview of the Ansys interface. Let's continue to my next lesson, where we will go over building our first 3D model in Geometry Modeler.